Khader, yesterday we have discussed on OSI
Yep.
model, correct? OSI reference model. So this was the model which was introduced in 1984. So it is having how many layers? 7 layers. Can you tell which are the layers of OSI model?
Application.
Yeah, application layer, then
Application layer and
presentation layer, session layer, transport layer, and then network layer, data link layer, and also physical layer. So how the data is going to flow from upper layer to the lower layer at the source end and at the destination end. So the data will receive from lower layer to the upper layer. Okay, so these are the things we have discussed. We have discussed on application layer, and we have discussed on presentation layer, session layer, and transport layer. We have to discuss on network layer. Now tell me, what is the responsibility of application layer? Khader?
yes, I can hear you.
Yeah, what is the responsibility of application layer?
Receiver.
So can you give the examples of application layer? Web browser, can I say?
Web browser.
Web browser for the application layer. Presentation layer. Encryption, decryption, compression and decompression. What is the responsibility of presentation layer?
BDF.
Yeah, so it will encrypt the data, it will decrypt the data at the destination end, it will compress the data, and it will then decompress at the destination end. And also what it will do, it is responsible of how representing the data, how it should be. It can be a JPEG, it can be a doc, it can be a text file, whatever it may be. Okay, and it uses a code language, that it can be used ASCII code or it can be FCD, any other thing. So the representing the data, responsibility of presentation layer is how data should be present. So that is the job of presentation layer. What is the job of session layer? What is the job of session layer? Managing the session, terminating the session, correct?
Ending, yep. Ending, yep.
Yeah, so managing and terminating the session. So for transport layer is what is the responsibility of transport layer? It can be, it uses 2 types of protocol. So which are those protocol it uses? It uses TCP and UDP. It uses TCP and UDP are the 2 protocols it uses. So whereas TCP is a transmission control protocol, UDP is a user datagram protocol. This is a connection oriented, this is a connectionless. This is slower communication, this is faster communication. Examples, so we have many examples here. And also the transport layer responsibility is sequencing and receiving the acknowledgement, and if data failure while sending, it will retransmit the data, and the flow control. So all these are the responsibility of the transport layer. So the next layer is your network layer. So what is the job of network layer, or what is the responsibility of the network layer? So these three layers actually we call physical layers. That means, so here in the network layer, we use some devices. So the devices we use like MLS switch, or we use router. So these are the devices we use. And here we use IP addresses. We use IP address. IP address again, we have IP version 4 or IP version 6. So here actually, and this network layer, it is also referred as a Cisco layer. You can just see here. What network layer is also referred as? It is also referred as a Cisco layer. Why it is referred as Cisco layer? Because most of the products, so what we use here, like, so the devices what we use, it is manufactured by Cisco. So the first priority will be given for the Cisco products. So that's why it's called as a Cisco layer. And it will make sure that end-to-end delivery. Suppose if two machines are communicating, so the data is moving from source to the destination. So here it will make sure, suppose if I'm 10.0.0.1, so here 10.0.0.2. This is example for LAN. Okay, so here the data is sending and the data is received. How you can identify whether these two pieces are communicating? By using a ping command. So we can use a ping command whether the data is sending, or I have a capability to reach out this machine. So how can I check? By using a ping command. So what here it will do? This is example for LAN. Suppose if I have, let me go here. I have one router here. I have some switch here. I have some switch here. Again, I have some router here. So some big network. If I'm having some big network, so I want to reach out from this network to other network. So let me draw here the networks. So this is the topology. Okay. So here we have a switch. So let me say here. So this is belongs to 10.0.0.0 network /8, and here this is belongs to 192.168.1.0 network, and here this is belongs to 172.16.0.0 network. Suppose I have a different network. So within this, so this is a local area network. Again, this is a local area network. This is a local area network. The data needs to send from this network to this network. How data is going? Data is passing through the router. So here, routers are the device which is having a capacity to reach out to find the routes for the destination. So that means router we use to communicate with the different networks. Why we use routers? To communicate with the different network within the same network. Suppose I will be explaining you on IP address. On the when we use the classes of IP address, you will come to know what is same network or what is different network, how it is going to be divided. All those things you will learn over there. Okay. So here we have 10 network. We have this network is different. This network is different. So I want to communicate from this network to this network. So I need a help of router. So without router, I cannot reach to the different network. If it is the same network, I can able to do without a router. That is, I can say this is a LAN, and here the connection between this router to this router, it will use WAN connection. You do you know what is LAN and what is WAN?
Yep, LAN is a local area networking. Yep.
Yeah, local area network. So what is the limit of local area network? It is having a limitation, right? Within a kilometer, within a 100 meter, correct?
Okay. Yep.
Yeah, WAN. So like it is a worldwide. So wherever I can able to communicate. So it can be 60 kilometer or more than that. So in between we have a multiple routers to come to link that cables. So like that we have multiple process or procedures we have, so we can link through the WAN connection. So to reach out from this now, suppose let me say, so this is belongs to India network and this is belongs to UK network. So how the reachability? So you know that the cables are dumped under the sea, right? Under the sea,
Yes.
the cables are dumped. You know that, right?
Yep.
Yeah. Suppose if I want to communicate with UK, so how the data is going to be flow? Well, if it use wired or wireless network, obviously it use wired network only. Okay. So for first the data from where? From the local to the required data center it will reach. So from there to UK, for UK data center it will go. So like that it will the communication which gets happen. Okay. So here network layer, it is responsibility of providing end-to-end delivery and also provide logical addressing that routers use for path determination. So what is logical addressing? IP address is also called as logical addressing. So that means when we assign an IP address to the devices, it has to the example here. Suppose, see, this machine IP is 10.0.0.1. This machine IP is 10.0.0.2. And this is 10.0.0.3. So this can be 1.1, 1.2, and 1.3. 192.168, 1.0, 1.1, 1.2, 1.3. So now, just assume I have only one router. Suppose if I just say one more router I will add here. One more router I will add, and I will provide a connection here. So now we have two paths to reach out. I have two paths here. Correct. How many paths I have? How many paths I have to reach this network? The data can go in this route or it can go in this route. It can choose any of the link. Correct.
Yep.
It can choose any of the link. So how data is go? So here, based on the routing, based on the routing protocols, it will decide which one need to be, what routing protocol we have configured. So all the metrics it will calculate. It will calculate with the metrics. So the value. So if I go with RIP, we have EHRP, OSPF, like many protocols we have. So based on that, it will decide. So which link need to be select to reach out this destination. The data can go where, if I call this is link 1 and this is link 2, it can choose link 1 or link 2, anything it can choose. So like that. So for in a van, if I take example of your van, we have multiple links and multiple routers. So how the data will get flow from one network to the another network. So based on the metrics, it will calculate all the metrics and it will route out the best route. It will do the path determination. See, that is what we call to reach out from 10.1 to 192.168.1.1 machine. It will do the path determination. How it will do? Whether the data need to take through R1 router or either it has to take through R2 router. It will do the path determination. So then only the data gets flow. So all this is a backend. It will be running. Clear? Clear? Khader?
Yeah, I can hear you. Yep.
Yeah. Is this point is clear?
Yes.
Okay. So next thing here, segments are encapsulated. So here, whatever the data which is received from the transport layer. So in transport layer, what the data is called? Data is called segments in transport layer. So that will be encapsulated and it will be sent to the lower layer. And inter-network communication, and also it will do packet forwarding. So what the data is called in network layer? The data is called in network layer is packet. Correct? Yesterday we have discussed on this. What data is called? It is called packet. So what it will do? So if it has to send the data which what we call, this is called, we call this as a packet forwarding. So the packet is coming to this, and here we have outgoing interface. Packet will go here or it can go here. It can be anything, any of the, or it can choose both the, so how we have designed the network, it will be designed, it will take the packet in that way. So that is packet forwarding we say. Okay, and also it will do packet filtering. What it will do? So here, see, the packet is moving 10.1. Suppose my destination, let assume here the destination is 192.168.0.0, 1.1. So here the packet need to be sent from this network to this network. So here it will decide whether the packet needs to go to this network or to this network. It will decide, it will filter the packet and it will move forward. So that is a packet filtering. And also the responsibility of network layer is makes best path determination, and also it does with the fragmentation. So PDU is a packet, and we have two protocols here. The routed protocols, that is IP or IPX. IP stands for Internet Protocol, IPX, Internet Protocol. And then here, next we have a data link layer. So the job of the data link layer is it performs a physical addressing. It performs a physical addressing. So this layer provides reliable transit of data across a physical link, and also combines bits into bytes and bytes into frames, and access to media using the MAC address. It will also do the error detection, and not, it will do only detection but not correction. And it is here, if I say this is my data link layer, okay, this is my data link layer, data link layer. This layer is subdivided into two layers. That is, one is LLC, another one is MAC. So here LLC stands for link layer. No. 1 minute. So here LLC stands for logical link control. Okay, so let me write down here LLC. Are you there?
Yeah, I can.
LLC stands for logical link control. Okay, and one more we have here, MAC. So MAC stands for media access control. Okay, so this data link layer is subdivided into below subdivided into two layers. One is logical link control layer and another one is media access control layer. Okay, so here this LLC, which is linked with the above layer, which is the above layer, that is a network layer, and this media access control, which is supports for the below layer, which is the below layer here, physical layer. Yeah, physical layer. Okay. Yeah. So what LLC will do? LLC will perform a link establishment. It will perform a link establishment, and MAC performs a media access method. So that means, so MAC is nothing but a physical address of, so we have a Ethernet. We have a Ethernet is the protocol here which is support. So we have a Ethernet standards, that is a 802.3. Okay, so here this NIC, I can say Ethernet card means NIC card, network interface card. This NIC is embedded with MAC address. Is embedded with MAC address. So this MAC address is of 48-bit address. MAC address is a 48-bit address. We have a MAC address. This MAC address is a 48-bit address, and also it is a hexadecimal. It is in a hexadecimal. Okay, how can I check the MAC address? So if I go to command prompt, if we go to command prompt by giving the command ipconfig /all. So here you can notice, suppose if I just go Windows key or go to command prompt, I can just find out my MAC address by giving the command ipconfig /all. So this is my wireless LAN adapter. You can see. So this is the MAC address we have. This is the MAC address. This one. Notice here. Have you noticed this one?
3C?
Yeah, this is the MAC address. So this is a combination of alphanumeric, that is hexadecimal. So hexadecimal is 16 bits, right? 0 to F. Okay. 0 to F. So that is 0, 0, 0, 0. It's a 0, 0, 0, 0, 1. That is 1, 0, 0, 1, 0. That is 2, 0, 0, 1, 1. That is 3, 0, 0, sorry, 0, 1, 0, 0. That is 4. So like this, it moves on up to, last one, 1, 1, 1, 1. So that is F. Okay. You know about it? Do you know? Khader?
No.
This one you know? You want me to explain on this?
Yeah, please.
Yeah, sure. You hexadecimal. So here we have this, it starts from like this 0, 0, 0. So that is nothing but 0. And here 0, 0, 0, 1. It is nothing but 1. 0, 0, 0, 0, 1, 0. It is 2. And here 0, 0, 1, 1. That is called 3. 0, 1, 0, 0. So that is 4. 0, 1, 0, 1. So that is 5. 0, 1, 1, 0. That is 6. And here 0, 1, 1, 1. That is 7. 1, 0, 0. That is 8. And here 1, 0, 0, 1. That is 9. And then for 1, 0, 1, 0, it is not 10, but I should say it is 8. Okay. And then 1, 0, 1, 1, that is B. 1, 0.
11C. 112C.
Yeah, 1, 1, 0, 0. So that is C. Okay. Then 1, 1, 0, 1. That is D. And then 1, 1, 1, 0. That is E. And then 1, 1, 1, 1. That is F. That is F. So this is a hexadecimal. Can you see here? Suppose if I just go here in the command prompt, here you can just see this is the physical address. See 3C91. So how can I say? So what is the value of 3? What is the value of 3? What is the value of 3? 0, 0, 1, 1. What is the value of C? 1, 1, 0, 0. Okay. And then 9. The value of 9 is 1, 0, 0, 1. Value of 1 is 0, 0, 1. And for 8, what is the value of 8? 1, 0, 0. For 0, it is 0, 0, 0. And then for 7, the value is 0, 1, 1. And for 4, value is 0, 1, 0, 0. And then for 8, value is 1, 0, 0. For D, 1, 1, 0, 1. And again, for 4, it is 0, 1, 0, 0. And for D, it is 1, 1, 0, 1. Can you count this one? How many digits we have here?
6. 1, 2, 3.
6 or 8? 8, no.
8, yeah.
8,
Yes.
8,
8.
8, 8. How many here iPhones we have? How many divisions we have? 6 divisions.
Yep.
1, 2, 3, 4, 5, 6. So 6 into 8. What is the value? We have 8 bits and 6 divisions. And 6 divisions. So it is nothing but 8 into 6. The value is 48 bits. Understood how it come 48 bits? Khader?
Yeah.
Understood is this? So this
yes,
is the MAC address of the wireless. So how I can just check that one? Here, how can I say this is a, suppose if I just go to network, we have a local area connections. So that is a Ethernet connections we have. You can see network connections. So this is my adapter, Wi-Fi adapter. I have connected to the Wi-Fi. So here this Wi-Fi is a wireless NIC. This is a wireless NIC. I'll show you how it is. So here, if I come, if I check for NIC, you can just see the images. See, this is a NIC card. This NIC card is embedded with the MAC address. Here, this is a wireless NIC. This is wireless NIC. So here for laptops and all, it is inbuilt with the wireless NIC. So this card is embedded with a chip. So that is in that chip, so the MAC address is binded. We cannot change the MAC address. So that is a permanent. MAC address is permanent. We cannot change. Whereas IP address, we can change it. But MAC address, we can't change. This part is clear?
Yep.
Okay. So here the data is called frames in data link layer. And here we have this one. So how data link layer. So it consists of preamble, the destination MAC address, source MAC address, and the data length, data, and FCS. So this is the frame. Frame consists of different fields. How many fields we have? We have preamble field, we have destination. DMAC means destination MAC address. SMAC is source MAC address. The data length, so how much data length it is. So it carries the data length, and here the actual data, and here is a frequency. This one FCS. So FCS is a checks what is that? 1 second. I've forgotten the expansion of that. FCS in frame. A frame check sequence. It's called a frame check sequence. So here any extra bits are added to the frame, so that will be detected through the FCS. So that is a FCS. These are the fields of the frame. You can note it down. You can take down this one. Okay. And then the next is physical layer. So physical layer, so the actual data is going to be sent through the physical medium. So my physical medium, it is a cable. Okay. So this is a physical media through which the data represented as electronic signals. So the data is called here what? Bits. Bits means what? What do you mean by bits? Bits means binary digits. Binary digits. Okay. So here, whenever the PC, so this is a source and this is a destination. So from upper layer to the lower layer. So this is a physical layer. So here connected with the cable. So here this is the cable, it is connected. So transmission medium. So physical medium through which the data represented as. So here the bits are converted into electrical signals. The bits are converted into electrical signals. So here at the receiver end, again that electrical signals. So that is a raw bits, we can say raw bits, or again converted into the raw bits. So electrical signals are converted into the bits, bits are converted into the frames, frames are converted into the packets, packets are converted into segments, segments into the PDU. So like that, okay. And here it does encoding also. It does encoding and decoding. So physical layer is responsible of sending the data and converting the frames bits into the electrical signals, and also at the receiver end, so that electrical signals is converting back into the bits, bits are converting into the frames. Okay, so that is the job of the physical layer. This part is clear?
One more time,
physical,
please. Yeah.
Okay. So next we have here data encapsulation. So what do you mean by data encapsulation? So whenever the data is sent from upper layer to the lower layers, so take down the, what do you mean by data encapsulation? So data encapsulation is the process in which some extra information is added to the data and to add some features to it. So we use either the OSI or the TCP/IP model in our network, and the data transmission takes place through various layers in these models. So that means what? So here we have upper layer data. So what is the upper layer data we have here? What is upper layer we call? It is called as a protocol data unit, correct? So application layer, presentation layer, and also we have a session layer. So where actually the data encapsulation is going to be added. That means in the transport layer, the data is called as what? Segment. So whatever the data it is received from the upper layer, for that extra information is going to be added in the transport layer. What is this extra information? That is TCP header. What is data encapsulation? Encapsulation is called. So the extra information is added to the actual data. It's called as a data encapsulation. Okay. And for next, it goes to the below layer, that is a network layer. Data is called as a packet. So here, what extra information which is adding? So this together, upper layer, TCP header, upper layer data with TCP header, together we call here as a data. For that, extra information is added. What is that information? That is IP header. Again, this completely, this is added here, and this completely IP header from here to here. This complete information is called as data in the data link layer. So here it is going to do frame check sequence, and also here data is called as a frame. FCS means frame check sequence, and it will add the LLC header, logical link control. So this header is added. This complete we called as a data here. In the physical layer, so here this is the data. So MAC header is going to be added. So here this is a bits. In the physical layer, this is called as a bits. At the sender end, what will happen? At the, this is a sender end. This is the bits. These bits are going where? Going through the cable. So this is a cable. It is a transmission medium. So this will send, these bits are again converted here into the electrical signals. These electrical signals converted back into the bits. So here again at the receiver end, it will, whatever it has done, it has encapsulated here, it will decapsulate. How it is going to decapsulate? It opens the bit, that is a packet or that is a frame, whatever you call. It opens here and it removes the MAC header here. And at the receiver end, what I am telling you. Then it moves to the data link. It removes the logical link header. And here at the network, it removes the IP header. At the transport layer, removes the TCP header. So this is called as a decapsulation. De-encapsulation. De-encapsulation or decapsulation we call. Okay. So that is it is called as a data. What is data encapsulation? Adding extra information for the data is called as a data encapsulation. And removing the extra information from the data, that is called as a de-encapsulation. Clear? Clear?
Yep.
So next, here you can see data encapsulation. Here we have a segment. So this is a segment which is in a fourth layer, layer 4. That is a transport layer. So here it is having the source port, destination port, and also data. The complete of this, it's going to be sent to the below layer. So this is a segment. It adds the source IP, destination IP, and the protocol. So the complete this, which is going to send to the below. So that is for a frame. So here frame is adding a destination MAC, source MAC, and also the ether feed. So here we have a, that is received from the upper layer, that is a packet, and also we have a FCS. Again, this will be sent to the, it will be converted, the frames are again converted into the bits in the physical layer, and it will send in the transmission medium. So here we have some analogy. So how OSI model works, you can go through with this. Kader, can you read the slide?
After riding your new bicycle a few times in Bangalore.
Little louder.
After riding your new bicycle a few times in Bangalore, you decided that you wanted to give it to a friend who lives in Dadar, Mumbai.
So you have, after riding your new bicycle a few times in Bangalore, so this is a new bicycle. So she has decided that this wants to be sent to one of the friend who stays in Mumbai, that is in Dadar. Okay. So here, this is the application layer. So this is a source host. In application layer, you have decided you have to send this cycle to your friend. Okay. In presentation layer, make sure you have the proper directions to disassemble and reassemble the bicycle. Okay. And here in session layer, call your friend and make sure you have his correct address. To send, you should know the address of that person, right? So you are making a call to your friend and you're communicating. That is, you're starting the session, managing the session, terminating the session, you can remember. And in the fourth layer, that is a transport layer. So source host, it is for how I can send my data is your bicycle. How I can send the bicycle? Can I send bicycle like all with assembled? I can't send in that way. I have to pack that bicycle, then only I can do courier or I can able to send, correct? Is it possible for me to send directly with assembled parts? No. So here, what it will do in transport layer. So that means data is dividing. That is a dividing into segments. So here, this is segment 1, this is segment 2, this is segment 3, you can see. Suppose if I'm having a 500 MB of data, so that data is divided into, so here 200 MB, this is 100 MB, this is 100 MB, like that. So the data is divided, that is the segments. So this is one segment, this is one segment, this is one segment. So here, disassemble the bicycle and put different pieces in different boxes. The boxes are labeled off. So we have 1 of 3, 2 of 3, and 3 of 3. So like that, they have labeled. So that is what the transport layer. Okay. And here we have a network layer. So put your friend's complete mailing address and complete mailing address, not yours. Sorry, and yours also. So that is senders and receivers address. On each box, since the packages are too big for your mailbox, and since you don't have enough stamps, you determine that you need to go to the post office. It is necessary to go to the post office. So now what you are going to do it here? The next data link layer. So you are going to post office takes a possession of the boxes, and you are here in the physical layer, the boxes are flown from Bangalore to Mumbai. So here in physical layer, it is moving through the, so transmission medium is air. So through aeroplane, its box is going to be delivered to the Mumbai from Bangalore. So now at the other post office receives your box. So this post office receives the boxes which is sent from the Bangalore. And here in the network layer, so who is the destination? My destination is, so it is written on the address. So upon examining the destination address, the other post office determines that your boxes should be delivered to your return home address. So then it is received to the upper layer, that is a transport layer. So your friends calls you and tells you he got all 3 boxes and he is having another friend named BOB reassembles the cycle. And then here session layer, your friends hangs up because he is done talking to you. Okay, so then the packet is arrived here at the presentation layer. So Bob is finished and presents the bicycle to your friends. Another way to say it is that your friend is finally getting him present. So here your friend enjoying riding his new bicycle in Dadar. Have you understood this one, this analogy? What I'm trying to explain for you?
Yeah, I do some. Yeah.
Okay, so how the data is moving on a network. So this is all about OSI model. Any doubts here? Any doubts? Khader, are you there?
Yeah, I can hear you.
Yeah. Any doubts for in the OSI model?
No, so far.
No, so far. Okay, do one thing. You can take a break for 10 or 15 minutes. So afterwards, we will continue.
Okay, thank you.
Okay, yeah. Khader?
Hi, ma'am.
Oh, hi, hi.
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 My name is Ahmed. I'm new student.
Oh, is it?
Hi, Ahmad. How are you, man? Assalamu
Ahmed.
alaikum.
Good alaikum salam, brother. How are you?
I'm doing good, man.
I am online today.
Yeah, mashallah.
Yeah, I'm just watching.
Yeah, that's great.
Are you able to understand, Hamad? Can you guys
Yeah,
turn on your web cameras?
I understand a little bit.
Okay.
Little bit.
Even madam, he also joined, Pawan. I
Okay.
think you already met him, right?
Yeah.
Yeah, so Pawan also, he also joined.
Okay.
Uh,
Hello,
maybe-
Pawan.
Hi, Pawan, are you there? I think you have given this one, right? Break.
Yeah, I was given the break.
Yeah, that's the reason I think. Okay, he joined already. Maybe he'll come back. No issues.
Okay. Okay. So what we'll do now?
Ahmad, if you have any question, you can ask madam, because Yashoda madam, and she's a corporate trainer for the many international companies.
Oh, okay. I need to know only one thing is my question is did we already start to Cisco from here, or we start? This is a few common things. So,
Yeah, this is a basic things what madam has started.
okay.
Yesterday we have explained the few things.
Okay.
Not completely.
Okay.
Basics. So you are in the right time. You have login.
Okay. Thank you very much.
Yeah, you are right time. You login. So no issues. So you can be comfortable with madam, because madam is very friendly, you know.
And this class they are recording. Yep.
Yeah, it's being recorded. So it will be uploaded in YouTube. Even the YouTube also, we are live now.
Yeah. I did.
Yeah, you can just open your YouTube. So it is live now.
Okay. Thank you very much.
Yeah. Hamad, did you install the Cisco packet tracer in your laptop?
I did one thing that's I don't know if it's exactly the one that's
So you are using Mac or Windows?
I'm using Windows 10.
Yeah, no issue. I think I will send you the link, or madam will send you the packet tracer link.
Yeah, she can send here from here.
Yeah,
and
yeah.
then I can...
Yeah, no problem. So madam will share the packet tracer link. I think same thing we can install. I will send you the WhatsApp. I think yesterday I sent you the Khadir.
Okay, Qadar, send me the link.
Yeah, I will send you. You can check in your WhatsApp. So I send you in WhatsApp. Just click on it. So it will take you to the Cisco packet tracer. You can log in with your personal email address, like your Gmail or Hotmail, whichever email address you have. So you can able to log in that.
Okay, I do now.
Actually, today, I had a big problem. So here, because my server is getting some memory bank. One of the memory has been corrupted.
Okay.
The server is a Dell server, so it costs almost $4,000 US.
Okay.
So I'm doing that work now.
Yeah,
I think madam will continue now and feel comfortable. Hamad and Khadir and Pawan.
Yes, sir.
Okay, be comfortable, so you can ask any questions. Pawan, are you there?
Yeah, yes, sir. Yes, sir. I'm there, sir.
Yeah. So how are you doing, man?
Yeah, fine, sir.
CCNA with Yashoda madam. Not
Yeah,
with...
yes, sir. Yes, sir. I know, sir.
Okay, then, guys. Thank you very much. All the best. Because I'll be there in the session.
Yeah, okay, sir.
Yeah.
So here, this is the Cisco packet tracer. Khader, yesterday we have installed this one. This application you have installed on your machine, right? Can you able to open?
No.
You can't open this one?
You want to open now?
Yeah. Can you just open it? So this application, the Cisco packet tracer, I'm using the version here. 8.2.0. This is my version. Okay. So here in the first row, you can see here, we have options for file options. You can open a new, or you want to save the application, save the file, you can save, or save as, we can do it. Okay. Or you want to exit or log out, you can do it. And in the edit option, you have an option of copy, paste, undo, and redo. And also we have options called preferences. I'll come to this part later on. So these are the important. Okay. In preferences, what are the changes I can do? Okay. And then here in the second row, you can just see, so this is the new. I can create a new copy, and here we have a open. This is a save. This is for print. So this is for set the name or email, any of the thing. And here we have a this one, zoom in or zoom out. This is for zoom in. This is for zoom out. And here in the third row, you can just see this is for selection. Suppose if I just take any of the devices here, I want to select all this device, I can go this and I can select it, and I can keep and drag it. Whatever, wherever I want, I can keep it. And this is for inspect. This is to delete. So I want to delete this, means I can delete here, just delete it off. Okay. And here, this is for resize. See, I want to resize, means I can resize it. If I select and I want to resize this, means I can resize this. This is nodes. See here, I can write the nodes. So this is a router 1. I want to name this router, means I can just take this labeling. I can say this one label or place a node. So this is a node. And here we have draw line. So if I take line, I can draw the line here, and I have a selection here. So I want to keep this in a one place, or I want to represent this in one. I can get this, go for the selection for rectangle or ellipse. So whatever we want, we can able to do that one. And here we have a protocol data unit. So this one also I will explain to you later. And here we have a colors also. I want to fill the color. I can select a fill color, and let me select, click OK. And here, if I just draw, so I can go with the color. So while using this application, so we'll practice this one. So then you come to know what are the things. So before that, moving forward, so here I want to explain you one more thing. So below the application, you can see here. So this is the timer. We have a forward button here. Below to that, this blue colored line, we have a multiple devices options. So here we have network devices, and here we have end devices. If you place your mouse on that, it will display over down. So you can see that is a network devices. This is end devices, and this is our components. This is a connections. This is a miscellaneous things. So miscellaneous, and this is for cloud. So if I select network, suppose now I want to, okay, let me delete off this one. Select and delete it off. I want to take two machines, two PC I want to take. How to take two PC? So where should I go? I should go for end devices. So here I have options. Next to that column, I have one option here. We have options like I can go for a PC, I can go for a laptop. Even if I want a server, I can go for a server. I want a phone, means I can go for a phone, or IP phone means IP phone. Tablet means tablet. So any of the things I want, I can select it off. So right now I don't want all these things. Let me delete it off. So first I will do lab here for two PCs. So here I will just take two PC. So how to form a network? So how can I form a network? Can I form a network by having a single device? I can't form a network by having a single device. At least minimum is two PCs. Maximum is, it can be any number. It is an infinity. Okay. So now I want to make connection between these two PCs. I want to communicate with these two PCs. Means how can I do that one? Can you tell me, Kader, Pawan, or anyone? How can I communicate between these two PCs?
Wireless.
This is not supporting for wireless. If I take laptop, this will support for wireless. This one is supporting for wired. So how can
Router.
how can I go for communication? What are the things it's required?
Router.
No, only with the two pieces. I want only with the two pieces. Let me call this lab is peer-to-peer communication. Peer-to-peer communication. Okay. So tell me, what are the things required? So take a note here. So to form a network, what is the required thing we have? We need, what are the requirements? We need devices, correct? So in my case, here I need PCs. Okay. So for that PCs, again, I need a cabling I need, and then I need to assign IP address. So these are the basic things, correct?
Yes.
Yeah,
Yes.
we need these all. So how can I do the communication now? First, I want to connect between these two pieces. So what should I do? Where should I go for connections? So here come below, next to the network devices and the devices, here you can see this orange color. So this we have a connections. So if you click on, So here further we have how many connections we have in the list, that many connections type it will display here. Okay. So here select a device to drag and drop to the workplace. So first one, if this one, if I select, you can read out below. Can you read here? Automatically choose connection type. So the
Yep.
second one, if I take, it will go for console. This is copper straight through. And here this is a copper crossover. So we will discuss on this cabling later on. So now I just go for an automatic connection. So let me take this automatic connection. And if I click on the PC, it selects the port and it will, I can place it on the another PC. So this is automatic connection, means the interface it will choose automatically. And the cable also, what type of cable, whether I should go with a crossover cable or I should go with a straight through cable, it will automatically choose. Can you see here dashed line? Suppose if I take this one, so if I connect from here to here, see here I have fast Ethernet 0. See, automatically if I choose, it will not display anything. No, it will not display any of the ports information. It will not display. Suppose if I go with this one, copper straight through cable, if I select this one, so it is asking me whether you need to connect for USB or for a fast Ethernet. If I choose fast Ethernet, and here also fast Ethernet, it is connecting. Can you see the difference? The dashed line, which is called this one, the dashed line, this is a straight line, is a copper straight through, dash line is a copper crossover cable. So what is this? Crossover and a straight line. So let me write down here. Straight through means this is for dissimilar device. This is for dissimilar device. So crossover cable we use for similar device. So now tell me, PC and PC both are similar device or dissimilar device? What type of cable I should use? I should go with straight through or I should go with crossover? Which one I should go? Are you with me?
Yeah,
Guys?
you will go the, if you want it, the one you wanna cross
Yeah.
the crossover.
Crossover. Why? Because these two are similar. So here you can just notice I have linked with straight through cable here. Can you notice here? I have linked with straight through cable here. So that means this laptop and laptop are similar device. It is not supposed to go with the straight through cable. So why? Because so while we have a color coding, so RX and TX, receiver end and transmission end. So for receiver end, it is a different wires it will use. For transmission, it is a different wires it will use. So for similar device, it is recommended to go with straight through cable. For dissimilar device, it is recommended to go with straight through cable. For similar device, it is recommended to go with crossover cable. Okay. So now I will just repeat. I'll just delete this one and I'll go with the connection of these two pieces. I just delete this one. Just delete it. So now I have selected the devices, that is the PCs I have selected, cabling also I have done. So next part is left with IP addressing. I have not assigned the IP address. How to assign IP address to the PC? How to assign IP address to the PC? So here, so I'll consider this is for local area network for LAN. So I'll decide here to go with the IP address. I decide here 192.168.1.1 and the IP which I have decided to provide here 192.168.1.2. Okay. So now how to assign this one? How can I do that one? Click on this PC and here we have a tab. In this tab, physical config, desktop, programming and attributes. So these are the options we have. In that option, we have to go for desktop. Okay. before that, I'll show you one more thing under the physical. If I just expand this and if I zoom in, can you see the button here? I can click on that, it will turn off. So if I turn off, you can see the link is, it's blinking in the red color. If I turn on, see, link is come up. Link is not down, link is up now. I can turn off and I can turn on the device as well. I can do that one. Okay. And here for desktop, let one.
We don't hear you.
So
Hello.
here
Hello.
I want to
Yeah.
assign a IP address. So go to IP configuration. Okay. So this is my PC0. This is the PC. I want to provide the IP address. I have two options here, DHCP and static. So by default, it selects with the static. Let it be static. So IP, you have to type it here, 192.168.1.1. And if you click on the subnet mask, it automatically chooses the subnet mask, that is 255.255.255.0. So right now in this scenario, we doesn't require to go with default gateway. So this will be explained later. And now close it. Okay. And here, if I go click on this, you should go for desktop and go to the IP configuration. What is the IP I should assign here? 192.168.1.2. And if I click on this subnet mask, you have to, it will select the automatically the subnet mask, it will be selected. So now two machines, I have assigned IP addresses for both the machines. How can I check whether both the machines are communicating or not? So that I can verify by going into the desktop. Under this, we have a command prompt here. Can you see the command prompt here? Go to command prompt. So here I should provide the command called ping followed by the destination IP address. For this machine, which is the destination? Can you say? Who is the destination here? 192.168.1.2. So
Yes.
where I am in? I'm in PC0.
1.1.
Ping is the command, space followed by the destination IP 192.168.1.2 and just say enter. So here you can read out the packet is, you're getting a reply. See here, reply from where? 192.168.1.2. So how many bytes? 32 bytes. Time is 1 millisecond and TTL time to leave is 128 seconds. How many packets are sent? Sent packet is 4 and received packet is 4. Okay, following?
Yep.
Father,
Yes. Yes.
what we did now?
Yeah, well, I'm following.
IP.
Yeah, we have taken two devices. So this we call peer-to-peer communication. Okay.
And do we use a LAN?
Hmm?
So these two computers we use for LAN, like
Yeah, this is
Yes,
a
yes.
LAN. See here, the limitation is, if I place a cursor, here you can just read out. See how many port we have here. Can you see under the port? Fast Ethernet 0, Bluetooth. Only one Ethernet interface we have. So how many connections I can do? Only one connection.
One. Yes.
Okay. Suppose, let me ask you a question. I have a small office. I'm working, my office, I have 10 employees. Okay. I have office, 10 employees are working in my office. Now I want to provide a network. That means all the files and folders need to be shared among all the 10 PCs. So how can I form a network?
Same IP address.
I have to go with
Yes.
IP address. So if I take, so okay, I'll follow you only. I just take 10 PCs now. 1, 2, 3, 4, 5. If I press control and if I select, it will come 6, 7, 8, 9, and 10. I have 10 PCs. I want to form a network here. Within a office means local area network. I want to form a network. How can I do now?
Peer-to-peer communication.
If I select this, see, I can go with this one. And here again, if I try to connect this one, I'm getting an error. This cable cannot be connected to the port. Why? So we don't have one more port here.
Yes, one by one.
Oh, one only we have. So what should I do in this? So for this, what we can do, we have a network device. So I have told you, right? In the first, we have a network device. If I click on this, under this, we have a routers, we have a switches, and we have a hubs. First, let me take hub here. If I take a hub, if I place my mouse here, how many I can add? How many fast Ethernet ports I have? 0 to 5. That means how many PCs I can connect to this hub?
5.
6 PCs. 0 to 5 means 6. See, 1, 2, 3, 4, 5, 6. Can I go further? No. It's telling that no available ports. Okay. So here I will show you. Suppose if I just click on the hub. Okay. So zoom in. Here we have a power button. Let me turn off the power button. We have an empty place here. Can you see here empty place?
Yep.
Yes.
How many interfaces we have here? 1, 2, 3, 4, 5, 6 interfaces we have. For all the 6 we have connected. Still, I have 4 PCs to connect. So for this hub, I have a empty place slots I have. I can add the slots. So which one I should have? If I click on this, can you see here PT repeater NM1CE? Is this present here? 1CE. I just take this one and I will add it. I'll add it. I'm adding some more interfaces to this hub and I'm just turning it on. Okay. So now you can see I can go with the further. Understood what I did now?
Yeah.
Okay. So now let me take here provider IP addresses. First, I will write down here what IP I decide. Let me give it in 10 network 10.1 and this one I'll get just 10.0.0.2 and here it is 10.0.0.3 and this is 10.4 10.0.0.5 6 8 9 and this machine I just provide IP address 10. So now if I start to ping, will it ping? Just I have named the IP, but I have not assigned the IP here, correct? Have I assigned the IP address here? Have I assigned the IP address to the PCs here? Guys, are you there?
Yep.
Yeah, these different IPs because the same.
Yeah, this is a different network. So for
Yes.
inside the machine, I have not. Just I have labeled the IPs. That's it. So first, I should go and assign the IP address to that PC. How to do that? Click on the PC, click on the desktop, go to IP configuration and provide the IP address. 10.0.0.1 and press the tab. So what is the subnet mask for this? That is 255.0.0.0. Just close it. And this one. So I have to repeat the same thing, configure the IP address in all the machines. So let me finish it off. I just go fast here. I have shown you how to do that one. Okay. So for this machine, 10.4, let me close this. And here this is for 10.5. This is 10.8. This is 10.0.0.9. Ten dot zero dot zero dot 10. Okay. So now, how can I check whether both the all the machines are pinging or the machines are communicating or not? How can I check? How can I check? Guys?
Yeah.
Yeah. How can I check whether machines are communicating or not? What is the procedure? What is the step? What are the steps to check whether I want to communicate from 10.1 to 10. All the machines? Again, 10.2 to all the machines, 10.3
So
to all the machines. How can I check that one? What is the
you use
procedure?
the you
Hmm.
use the last one, 10.0.0.10.
Huh. Yeah.
For
How can I verify whether machines are communicating or not? What should I do now?
You check the IP address for
IP address I
10.0.0.
have already added. You can show here. You can just observe here. See here. If I place my mouse here, IP address for fast Ethernet I have assigned. 10.1 is assigned. What is the next step? How to verify? What should I do?
A requirement of device, BZS cabling IP address. You use that requirement again.
No, IP address is assigned, no, already, Ahmad.
Okay. Communication. Where communicate? Where communication does?
How to check the communication now?
I'll be on the mute few seconds.
Tell us now. Next time we'll remember.
Huh?
Tell us now. I will remember next time. Now because
Okay, no, just because no, it should be the interactive session,
Yeah.
right? Because you keep on explaining, so you should be able to understand.
Yes, you're right.
Yeah, that is very important. So just we have to check the ping with the which IP address you want to check the communication.
My understanding, I thought that is 10.0.0.10
See,
for the receiver, last computer.
yeah, see, right now this is 10.1, 10.2, 10.3, 10.4, up to 10 PC connected to the switch, right?
Yep.
Yes.
Okay, so now how to check these things? So just go to the open the PC icon. Okay, say example like 0.1. That is 10.0.0.1. Open that PC, click on the icon, go to CLI, ping with 10.2, 10.0.0.2. So if they are they are connected, okay, they will reply from the PC2. That is 10.2. Yeah.
Okay, so to verification is click on the machine.
Driver's license and medical card, please.
Yeah. Click on this machine, go to desktop. So here we have a command prompt, and here I want to ping to which is my destination. For this one, 10.1, 10.2 to 10.10 or the destinations. I can select any of the thing. I can select any of the thing. Okay.
100010.
Okay, so here what should I do? I have to provide the ping command followed by 10.0.0.2 is the destination. See here, I'm getting a reply. Can you see? So
Yes.
this is how I can verify whether machines are communicating. Means I should get reply from the destination host. So this is my
Excuse me.
destination host.
Hello.
Yeah.
Teacher, give
Yeah.
me like a 10 minutes. I become someone come to me.
Ah,
I
yeah,
need-
sure. You can. Okay. And here, one more thing I'll show you. We have here real time and simulation. Can you notice these two things? Real time and simulation.
Yep.
Yeah. If I click on simulation, here I have edit filters. Go to edit filters. Show all or none. Click on show all or none. I just click on ARP and ICMP and just close this one. Now I have told you we have a PDU here. See here, if I place this one in the third row, so last but one, that is a PDU. Add simple PDU. What is PDU? Kader? Kader, what is PDU? Have we discussed on this?
PDU.
Yeah.
Section.
Protocol data unit. Application layer, presentation layer, session layer. What PDU is called in transport layer. Yesterday we have discussed on this one. Okay, I have a PDU here. If I just take this packet, one more way of pinging here. Okay, I just put it on source machine. I just click it on destination machine. 10.3 is my destination. If I just take, see here, I have a packets. These are the IP packets. Just click on this play control. Packet is moving, going to the hub. Hub is forwarding that to all. Okay, so can you just see here again, it is sending to all. So how the packet is going to be flow. This is how even I can just check whether packets are going or not. We can check. See, this all rejected. So this one is getting a tick mark. So tick mark means here packet is sending a reply, received a reply, sending a reply. Okay. So these all are not the proper destination. So that is why it has rejected the packets. It has discarded the packet. And here you can see successful 10.1 source, destination is 10.3, and the packet which is using for this is ICMP protocol. And here the time taken. So multiple things you can just see. And here you can verify whether both the machines are pinging or not. I just delete it off. I repeat the same thing again. I take a PDU here. This 10.3 is my 10.4 is my source. 10.8 is my destination. Okay. I just click on the play button. See 10.4. Moving to hub. Hub is broadcasting that packet to all the machine because hub doesn't know who is 10.8. So it is broadcasting that packets to all the interfaces. 10.8, again, packet is sent to hub. Hub is sending to all the machines because hub doesn't know who is 10.4. Can you just check out here and observe here? Tick marks will come for source and the destination. If it is a proper source and proper destination, that packet is reached, and here you can see the result. Still it is in progress. Here, status of the packet is in progress. So whether that packet is successfully delivered or not, you come to know here. Here, check mark. If I click on this packet, okay, you will get the details. See OSI model, in layers and out layers. So this packet is coming from out layer to the in layer. So that is a layer 1. So port fast Ethernet 0 is receives the frame. So these are the details you can just see. And here we have layer 2. Can you read this one? The frame destination MAC address matches the receiving port's MAC address, the broadcast address, or a multicast address. Device decapsulates the PDU from the Ethernet frame. So at the device, source device, and the destination is 10.8. So if I go for inbound PDU details, here we have a frame, Ethernet frame here. So we can see here preamble. So the source address, destination address, source MAC, destination MAC, and the type field, data field, FCS field. So this is an IP header. This is an IP header. So like this, we can see the details of the packet as well. Clear? This part is clear. If I don't want, so just delete it off. Instead of simulation, come back to real time. So you can work normally. So here, how can I verify? By going to machine, going to command prompt. I have to provide the ping followed by the destination. This is one way I can verify whether machines are communicating or not. Another way, I can go in the simulation and I can take a PDU, just drop that packet from source to the destination. If you click on the play control, the packet, how the packets are flowing in the network, you can notice, you can verify, you can observe it. Okay.
Okay.
Yeah. Any doubts?
So the question is, when you make a bean or command, you can use the one starting for 10.0.0.1.
No,
or you use
directly it will not work. Ping is the command. So that is the prefix we have to fix in front of the destination address, destination IP.
Okay.
Okay. Without ping, you can't just, you are telling me that, let me, okay, I'll show you. So you are telling me you have to type directly 10.0.0.3. It will not work. It is an invalid command. So you have to
Okay.
prefix the command. The command is ping.
Okay.
Any other questions?
No.
One more thing, guys, because Khadir, the ping stands for packet internet grouper. Remember that.
Okay.
Khadir, are you there?
Yeah, I can hear you.
Yeah, Khadir, the ping stands for PING, packet internet grouper. We can see it will send us. It will send the 4 packets. Okay, it has to receive the 4 packets. Means it use ICMP protocol, Internet Control Message Protocol. This is the protocol ping command used to check the communication between the any 2 device. Understood?
Yep. But
Yeah,
I
see
have
exactly.
a computer here, you know. That's
Yeah.
I was running 10 computer, we have it. And the bean, if I want to check, do we start first computer or the second one?
You can communicate anything because you know
Okay.
there is the rules to communicate. See, if you want to travel because you are using the car, right?
Yep.
Okay, the car will travel with the petrol, diesel, gas, electric.
Yep.
Right. So this is the protocol. Okay, the car is the packet. Okay, the people who is sitting inside the car, that is, we'll call it as data.
Okay.
Understood?
Yep.
Okay, what is the objective for this? Means how do you transport the people from one place to another place? Okay, some people they will use the different car. They'll use Mercedes, BMW, Rolls-Royce, or Toyota, any car. Okay,
Yep.
that car will call it as we'll call it the packets. To travel the packets, there's many protocols. Okay, how you will carry the packets? The packet will be carried based on your protocols.
I'll show you some video on this. You come to know. Okay. So we
Okay.
have an animation on the OSI model. You just observe this video. You'll understand. So how the packets are flowing in the network. So how the cables are taking that packet and all those things it is explained here. So can I play this video?
Yep, you can.
Is
You can share the link, madam, to him, to
yeah.
Kadir. Okay, share the link. I think he will watch it later.
Yeah, you
Okay.
can do that also. I'll
Yeah,
just
okay.
share this video.
Okay.
I have pasted in the chat. You can just watch this video. You'll get some idea.
Okay.
Okay. So next, what we will do? Should I go with the basic, this one only?
Yeah, I think just now you connect with the router, like now you use one router.
Before see, first thing, we have a network devices. So what are the network devices we have? You understood, right? Why have I used hub here?
Yep.
Why I have used hub here? What is the reason I have used hub here?
The hub,
Yeah.
network service, network device.
See, in this scenario, here, this is only 2 machines I have connected. Here I have more machines. I was not able to connect directly to this machine. So with the help of hub, I can able to form a network with all these machines. Correct? Multiple devices I can connect to the hub and I can form a network. So here all these machines are in the same network. They can able to communicate. Yes or no?
Okay. So the hub, it means you can connect multi
Yeah.
computer. Okay.
More devices we can connect and we can able to communicate. Okay. So we have network devices. So these network devices, we have hub is one network device, and also we have a switch. We have MLS switch. So MLS stands for multi-layer switch, multi-layer switch. And here again we have router. And also we have firewall devices. So we are concentrating on these 4 network devices. Okay. So here hub is called a layer 1 device because it works in the physical layer. It works at the physical layer. That is why I call that as a layer 1 device. So here switch is a layer 2 device. Switch is a layer 2 device. So why? Because it works in the data link layer. It works in the data link layer. Okay. And then this MLS switch, it's called as a layer 2 and layer 3 device. Layer 2 and layer 3 device. Why? Because it works on both the layers. That is data link layer and also network layer. Network layer. That is why it's called a multi-layer switch. Okay. And here we have a router. So router is called as a layer 3 device. Router is called as a layer 3 device. So why? Because it works at the network layer. It works at the network layer. Okay. Fine. This part is clear?
Yep.
Okay. So next here, I just show you. This is the one topology we have designed. I will use one more device here. We have a switch. Here, I have a switch. I just go with the 2960 switch. I select and I will go with multiple pieces. 1, 2, 3. So I have multiple pieces here. So now what I have done, I have formed a network in the hub, right? The same way here also, I'm just going to form a network. Okay, I'm just going for providing the connections here. Provide connections from switch to PC, switch to PC, switch to PC, switch to PCs. Okay, switch to PCs. See here, how many ports I have in this switch? How many ports I have? Can you just see here? First Ethernet 0/1 to first Ethernet 0/24. That means 24 PCs I can add. And also we have 2 gigabit Ethernet 0/1 and 0/2. So totally we have 26 ports. That means 26 devices I can able to add to this switch. Okay. So in the previous example, that is in the hub, I have shown you I have to assign the IP address. For individual machines, I have assigned the IP address. Yes?
Yes, yep. It was 6
Okay.
and you added 2 more.
Yeah, 10 machines was there. 10 or for all the 10 machines, I have assigned the IP address. Manually, I have went to that machine and I have assigned the IP address. So now tell me, suppose in my company, I have thousands of employees. I have thousands of employees. For all the thousands employees, for all the 1,000 PCs, I have to go and assign the IP address. Is it possible for me to do it in a quick or in a fast way? How much time it will take for all the 1,000 employees I have to assign IP address? How much time it will take? Here itself, you have noticed for each and every machines we went inside this machine and we have assigned the IP address. Yes or no?
Yes.
It was taking too much time. Okay. So here what I will do, this time I am not assigning a IP address manually. I'm just assigning the IP address automatically by using a DHCP server. Okay. We'll learn how to do that one. So this is my switch and I have my PCs I have connected here. I will go for network, end devices and select, I'll take one server. So this is the server. I call this server as a DHCP server. I call this server as a DHCP server. Okay. And I will connect this server to this switch only. I'll connect this server to this switch. So how to configure the DHCP server? So I'll decide here. I want to assign some IP address to this. Manually, I just assign here 20.0.0.1 or 100. Let me take 100 is my IP address of this DHCP server. So how to first assign manually IP address for this DHCP server? So go to IP configuration. So static IP I will assign for DHCP server, that is 20.0.0.100, and just press a tab here. It auto completes the subnet mask. Manually IP address I have assigned. So for server here, if I click on, we have one extra tab for server, that is a services tab. You can notice here. And here we have an option under this DHCP. Okay. So you can see here DHCP service by default it is turned off. We have to turn it on, this one. And full name I just give here lab1, basic lab1, or any of the name you can provide it. Default gateway I'm not using right now, so I'm not giving. Even DNS server also I'm not using. I have to mention it here start IP address, that is 20.0.0.0 it is there. Let it start from 0.0.1 and subnet mask is okay. Maximum number of hosts you want, I want 20 IP address or I want 1,000 IP address. So that means I can select that many. I have to design all that. So right now I will give here 50. Okay. After that, click on add. See here lab1, 20.1, 50 IP address. I want to assign it. So it is taken and just close it. So that is DHCP server we have configured. Now how to check whether IP address or received on the PCs or not. So to do that, to verify that, click on the PC, go to desktop, go to IP configuration, click on DHCP. See, requesting IP address, DHCP request successful and it has received the IP address that is 20.1 to this machine. Close it. Go to all the machines and click it on DHCP so that it's taking time. 1 minute. Go to desktop, IP configuration, DHCP. See 20.2. And here also desktop, IP config, DHCP 20.3. For this machine as well, go to desktop, IP configuration, click on DHCP. So it receives the IP address 20.4. For PC 14, click on that, go to desktop, IP configuration, DHCP 20.5. Desktop, IP configuration, DHCP 20.6. The same thing, we have to repeat it on all the machines. We have to click it on DHCP. It will take, okay, 20.7. And here also, I'm just clicking on desktop, IP configuration, DHCP. Okay, so have you observed here how DHCP provided the IP address to all the machines? Have you observed? Guys,
Yes, I can hear.
understood this one? How to configure the
Can you
DHCP
explain
server?
the switch? Can you click the switch or how many?
We can do it for hub also.
Okay.
I can add the server to hub and also there also I can do it.
Okay.
Okay. So now I want to verify whether machines are pinging or not. As I have told you, I can just, this is a layer 2 device. This is a layer 1 device. So let me write down here. This is a layer 1 device. If I say layer 1 means which layer? Layer 1 means which layer?
Layer 2 device.
Physical
Switch.
layer. Layer
Okay.
2 means which layer? Layer 2 means which layer? Data link layer of the OSI model. Layer 2 means which layer?
Layer 2.
Yeah, which layer?
Physical layer.
Data link layer. Layer 2 is data link. Layer 1 is physical. Okay.
Okay, yeah, you say layer 2 devices and DL network layer.
Router. If I select router, suppose if I just come here, if I place a router here, and if I add the machines, so for router, we go with the switch, and here I have a PC. So let me add it here and add it to PCs. So if I take a router, router is which layer? Works in which layer?
Network.
This is a layer 3 device. Layer 3 device, network layer, correct. Okay. Fine.
Yep.
See, the difference between hub and switch we should know, and the difference between hub, switch, router, all the differences we should know. What hub will do? Hub will broadcast the frames. What hub will do? Hub will broadcast the frames. Broadcast the frames. Okay. What switch will do? Switch broadcast the frames only for the first time. Only for the first time. Okay. What router will do? Router, it will not do broadcast. Router will not do broadcast. Now tell me, what do you mean by broadcast, multicast, and unicast? Any idea on this? What do you mean by broadcast, multicast, and unicast?
No,
No idea?
no idea.
First, let me explain this one. Okay. So here, broadcast means one to all, sending information from one to all. One to all. Multicast means one to groups, one to some groups. Okay. And here unicast means one to one. One to one. Okay. What do you mean by that? So I want to just show you here. Okay, here. See, in a hub, I have multiple machines here. I want to send packet from 10.1 machine to 10.4. That means I have selected here unicast communication. I want to send. Okay, here in the session, how many of you are there? So who are the participants? We have Kader, we have Taj sir, and we have Pawan, and we have Hamad. Are they all there, sir?
Two of them, I think, left.
Yeah. Now
Ahmed.
I'm just giving the session. Who can listen to this session? Whether all are listening to the session or only Kader is listening? Who is listening to the session?
Me.
Everyone who is there in the session, all can able to listen to my session, right?
Actually, they are watching in YouTube from the YouTube.
Okay, fine.
Yeah,
Yeah.
I'm seeing that.
Kader, are you able to understand what I'm explaining? See,
Yeah,
broadcast means I want to send the information or I want to send a packet or a frame from 10.1 machine to 10.4 machine. Here, hub is the device. It will not do multicast or it will not do unicast. What it will do? Why? Because hub is not an intelligent device. Hub doesn't read any table. It will not read any table. Just it simply receives the packet and it will send that packet, sends that frame to all the machines. See, each and every machine. Suppose if I click on this PC, if I come to physical or a config, you can just notice the MAC address of this machine. Where the MAC address of this machine? POS Ethernet 0. If I click on, here you can see this is the MAC address. MAC address. This is the MAC address. Control C and I just paste this MAC address here. Control V. This is the MAC address of this machine. So like that, each and every machine having their own MAC address. Each MAC address is different. It will be never same. MAC address will be never same. Okay. IP address is also never. I can assign the same IP addresses to both the machines. So this MAC address is different. This is 00450. This is 0007. So we have a different MAC address. This hub, what it will do, whenever the information or the data is sent from this 10.1 machine to 10.4 machine, I am sending that packet to only that individual. That means I want to talk only to the Kader. Okay, but in the classroom, if I am in a classroom, if I call out Kader name, who will answer? Kader will answer. Whether only Kader has listened to that, for whom I have called, only Kader has listened? No. Who are there in the classroom? Everyone are listening to my voice. Yes or no?
Yes.
Here also same thing. In hub also same thing. Whenever I send a packet from 10.1 to 10.4 machine, see here, I have shown you in the simulation mode, I have shown you that take a PDU, drop a PDU here, just delete it off, take a PDU, top 10.1 to 10.4. If I just click on the control, see packet is sending. It has to send only for the 10.4, but hub is not doing that one. What hub is doing? Hub is sending to all. So this we call as broadcast. What we call that as broadcast. Why? Because hub never do it. See, when it's sending only who is 10.1, he receives and he will answer that and he will accept that packet. Okay, whereas hub, it is not going to recognize who is 10.1. It is not doing because hub don't have that capacity to do. So that is why I can say hub is in a it works only in a layer 1 device. Okay, so it's my machine is hanged. One moment. Okay. Okay. So just delete it off here. Close it.
You are using 2 computers or 1 computer, madam?
One only, sir.
Because in packet tracer doesn't consumes more memory, right?
Yeah. See,
You are following Khadir.
No, I'm
Are you
yeah, I'm
following?
with, yeah, I'm listening.
You're
Able
following,
to
right?
understand?
Is it getting bored or what?
No, I'm getting. I'm paying more attention.
Yeah.
Yeah.
So the same thing now I'll show you in switch also. Okay. Switch, as I have explained you, only for the first time, it will send the broadcast until and unless it learns the MAC address. You can just notice here, if I go to switch, I can even configure this switch. CLI mode we have, and I can come to this machine. I can go to the next mode. If I give here, show MAC address table, you can notice my MAC table is now empty. I don't have anything because I have not started to send the frames in the network. Okay, now what I will do, I just come to simulation mode and I'll take the PDU. I take the PDU. I drop from PC12 to PC13 machine. Now I'll click on the play control button. See, now switch is going to broadcast that only for the first time. See, it is broadcasting to them. And here PC13 is sending reply to the switch. Switch is sending that with a unicast. PC12 only receive the frame. It is not broadcasted. See here, now also here it is sending only for the PC13. Every time it is not going to send for everyone. You can check here in the switch table. If I come and if I give you a show MAC address table, you can notice that MAC addresses are learned for first Ethernet 0/1 and first Ethernet 0/3. That is 0001 and that is 00E0. So this is the MAC address of these two machines. MAC addresses of which machine?
Broadcast one.
Yeah. MAC address of PC12 and PC13. You want me to show? You can check out here. You can check out here. Come to physical machine. Come to config. So first Ethernet 0. You can notice 00142836229. Okay, if I come here, you can just see here. See, this is connected to FA01 interface. Can you see here FA01 interface? And this machine is PC13. Sorry, physical config first Ethernet 0. And here MAC address is 00E03B37. You can notice that MAC address here, it is there. Clear? What switch will do? Switch learns the MAC address. So only for the first time, switch broadcasts the frames. For the next time, it will do unicast communication. Okay. So next, how will come for router now? Now, this is different network 10 network. This is different network 20 network. Suppose if I connect, okay, let me delete one machine here. I need one interface, so I'm deleting this machine. I just go for connection between hub and switch. Okay. So now you can see if I'm in a different network, I'm not able to communicate from this network to this network. Okay. Suppose if I come to simulation mode, okay, and if I take a PDU and if I drop from 10.2 to 10.8 machine, you can notice one thing here. Okay, so let me send a packet. This 10.8 belongs to this network only, but still packet is moving to the switch. Even though this is not in the same network, these machines are the broadcasting. Why? Because hub is a broadcast device. It is sending a broadcast message to all. Each and every time it is sending. See, switch is not responding. It's dropped the, it has dropped the packet. It has dropped the frames here itself. Why? Because it is not belongs to this network. Switch is limiting that one. It is denying that packet here itself because that MAC address is not present. It is checking for that MAC address entry. MAC entry is not there. So it is rejecting the packet. See, hub, every time it is sending the broadcast messages. The problem is here, if it receives the broadcast message, the network, it is impacting on the network speed. It is impacting the network speed. So that means broadcast messages slows down the network capability. So that is the major issue. Getting Kader?
Yes.
Okay. So now, okay, this is rejecting the packet. I have two different network now. I want to make communication. I want to ping successfully from 10 network to 20 network. How it is possible? How can I communicate successfully from this network to this network? Now, if I just see, I'll show you here also in command prompt. My network is 10.7. I'm in 10.7 machine. Go to command prompt. Go to command prompt. I try to ping 20.0.0.1 machine. That means from 10.7 to this machine. I have a communication link here. So I try to ping from this is a 20.1 machine. I try to ping here. Is it possible for me to get a reply from them? No, I am getting a error. ICMP error I am getting. That is request timed out. Why I am getting request timed out? There is no reachability from this network to this network. It's not able to identify. So now to achieve this, we need a router. To achieve this, to communicate between two different networks, what we need?
Router.
We need a router. Now what I'll do, just cancel it. Cancel it. I take some router here, take 2911 router, and I form a connection here from hub to router and also router to switch. How to configure the router now? So the IP address here is 10 network. Here this way it is 20 network. What I'll do, I just decide to provide the IP address here 10.0.0.254 and this side I decided 20.0.0.254. Okay, 254. So how to assign IP address now? Go to router. Go to CLI. We have to provide no here. Provide enable. I give the command show IP interface brief. Can you see the details of the port? That is gigabit Ethernet 0/0. IP address is unassigned. And the link is, what is the status of the link? It is down only here, down and down. Okay. So now I have to assign the IP address to the interface. Means, see here, this side I have assigned gigabit 0/0 is the interface I have attached. Another side I have attached to the link gigabit 0/1. Okay. So first I need to go for configure terminal. I want to go to that interface. To move to that interface, the interface type is gigabit Ethernet and interface number is 0/0. Should go to that interface. If it is taking config if means you are in the interface mode. And here I have to assign the IP address. IP address. What is the IP? 10.0.0.254 followed by the subnet mask 255.0.0.0. Enter and should say no shutdown is the command to make that interface up. See, now it is turned to green color. Link is turned to green color. Okay. And again I repeat to the other interface. Exit from here. Go to interface gigabit Ethernet 0/1 and the IP address I have decided here is 20.0.0.254 followed by subnet mask. Enter and no shutdown is the command we have to provide. No shutdown. Enter. And how to verify whether what IP I have assigned here? To do that, show IP interface brief. INT means interface is the full form. BRI means brief. So SH means show. You can notice gigabit Ethernet 0/0 10.0.0.254 is the IP I have assigned. Gigabit Ethernet 0/1 20.0.0.254 is the IP I have assigned. Can you see? Okay.
Yeah.
So now if I just check to ping from 10.3 to this machine 20 network, any of the IP, go to command prompt ping 20.0.0.3. Enter. Okay. Why it's not reaching? Why? Because in all the machines here I have to provide the default gateway. Okay. So to reach out this network to this network, the default gateway for this network is 10.0.0.254. Here I have to provide 10.0.0.254. Okay. For all the machines, Control C, I just go to the other machine that is 10.2 and here also I paste the same thing. Only for this two machine right now I will provide the default gateway. Okay, Control V. Let's close it. For this machine, I'll assign it in server itself. Go to the server because DHCP is there now. So go to DHCP and provide the default gateway. Default gateway is 20.0.0.254. Okay. Just add it. So here I'll give lab2 default gateway 20.0.0.254 20.1. Just click on add. So this lab one I will delete it off. I just remove this one. Remove. Okay. Desktop IP configuration for this machine default gateway 20.0.0.254. Click OK. Now I have to come to desktop, click on IP configuration, click on static and again click on DHCP.
There you have to practice every day.
Yeah, I have to, man.
Ah. See, a lot of things are coming.
A lot of things coming here. So many communicated.
Why it's not taking DHCP default gateway address? It's not taking now, sir.
Hmm?
It's not taking default gateway automatically. I have assigned it, but still it's not taking.
Did you assign the IP address for server?
See, this is the server. 20.100 default gateway is 20.0.0.254.
Okay.
For services for DHCP, I'm just providing it here.
Assign IP address here.
Assign 20.1. 20.11 it's given.
Starting range, subnet
Yeah.
mark.
Yeah. On why it's not taking? It has to take the default gateway in
yes,
all the machines.
Server
Huh?
pool, you remove the second one.
Which one?
Second server pool, that one.
This doesn't matter. Nothing happened. That is the default one. It will not remove. This is the present. See, this is the default gateway.
Mm-hmm.
Start IP address I have given for 20.11. From that to 50. So desktop for 20.100.
And click on DHCP from the client.
Okay, we'll do one thing.
Switch for you have given the IP address for your switch.
1 second, sir. What I'll do,
Hmm.
sometimes it will, the log files, it will be lagging here itself.
Ah.
Let me take a new server here. Take the server and connect it here. I'm just repeating. This is my DHCP server. So configure static IP first. Go to desktop, IP configuration. 20.0.0.100 subnet mask and the default gateway 20.0.0.254. So come to services and here come to DHCP. Click services on. So here I'll just say pool 1. Default gateway of that machine is 20.0.0.254. Stored IP, let me assign from 20.101. 20.101. And here I'll give 20 and add that into the pool. So these are the details. Okay. So let me close it here. I want to just come to IP configuration. Click on static. Click on DHCP. Or else we'll do one thing. ipconfig/relieve it will work here. Huh?
No, it will not work. Release command. Go to server, man. Go to server. No, there is a issue with the only server. Just check the server.
IPL. What is the issue?
10. Okay, service, go to service. Just delete this one, pull.
This pool.
Yeah.
Okay.
So now you create once again. Your DN is 8888. Okay, so subnet mask is correct. So it is taken. Okay. Now you check now.
Maybe it's taking time to refresh, I think.
Hmm.
Here 20.1 now. .7. Same thing it's taken.
Just go to the server. This server is no, not power with the rights.
.8. But default gateway, why it's not taking, I don't know. It has to provide default gateway also, no?
So then I think you put this all ports into one VLAN one. It is in VLAN one, right?
That and all not required, sir. It has to provide it.
Then open the server.
By default, it is in the VLAN 1 only.
Go to IP address, check the IP address. What IP address, server IP address is?
Checked.
0.100. Gateway. Change the gateway. Use some other value. Okay. Delete this and create one second. Or delete and create one second. I'm showing over.
Okay, we'll do one thing. I'll just remove this one. It's taking, I don't know what is the problem. That is the procedure. And just remove the server. I go for static IP only. Okay. So here, come to IP configuration. Come to click on static 20.0.0.31.
254.
I'll give here, and subnet mask and the default gateway 20.0.0.254. Sorry. Yeah, we have assigned 254 only, na? Yes, 254. Okay. Just click OK. And for this machine also, PC 18, IP configuration, static 20.0.0.32, 20.0.0.254. Okay. Okay. So now I'm just trying to ping from 10.1 machine to PC12, that is 31. Command prompt ping 20.0.0.31. Here, getting a reply. I can able to communicate from 2 different networks. Clear?
Yep.
This part is clear? If I try to ping again for 20.32, first packet gets failure, the next 3 packet gets successful.
Okay.
First packet's failure. Getting a reply from 20.32. So I am in 10.1 machine. Clear?
Yep.
Okay. So we'll stop it here.
Other, if you want to go for work, you can tell us directly, no issues.
Okay. Yeah, I always go 130 work.
Yeah, no problem, because I think you should go back to work, right?
Yeah, 130. Yeah.
Yeah, no problem, because we will stop the sessions. Madam, you can stop recording.
Oh, yeah.
I think tomorrow we can continue.
Hmm.